So again, welcome to the 42 Wolfsburg Fireside Chat series, where we invite folks from around the tech universe. And indeed, I now see Blaise in the waiting room. Hi, Blaise. Wonderful to have you.
Hello, Max. Testing.
Hello, wonderful. I was about to do the introduction part where, you get, of course, embarrassed and your song sung, and you thought you might be smart and skipping that bit. But to be honest, you're also giving me a little less adrenaline and attention to see if you show up in the end or not. Great to have you. Thanks for joining us. Blaise, this might be also an opportunity to learn a bit about 42 in our universe. We have invited the next generation software engineers that we train in Wolfsburg, but we've invited the international community. So there are folks from Sao Paulo to Tokyo, from Morocco to Helsinki, who are studying in a peer learning environment. So as I always point out, that's how the real world works. If you want to check in code in the Google code base, you show it to peers before you do that. And that's how a lot of learning happens in the real world. That's why I was very convinced by the pedagogical model, and we'll get to speak a little bit about that later. But before we do, as promised, I want to embarrass you a little bit, share a bit about our history. We met back in the Google IoT expedition in 2015 when I was in Mountain View, and Blaise was, as he still is, I believe, up in Seattle running his team, and then got to a bit more intense work around future devices and AI and health and well-being. I think I leave it there because that was obviously Google internal work, but not too much later Google bought Fitbit, which I still think might have something to do with the conversations that we had. I really, really value Blaise's perspective on the future of AI, not last because it is one where we all keep our privacy and there is competition between all different actors and different AIs competing with each other. Very compelling, and to be honest, one of the few visions for AI and society that is neither utopian or dystopian, right? I think it's somewhat realistic. I hope you share some of your thinking and how it evolved over the last year and a half or so, since we don't have as much time together anymore. You came, I'm still thankful for that, to Berlin in 2019 to speak about as extension of our identities. And I did rewatch that presentation you gave, and I'll share it with this community as I think it's quite relevant to how we conceive AI and the different AIs and that whole ecosystem. In a very short, condensed version, Blaise did some really cool work at Microsoft and then got hired over Google, where he now leads a team of about 300 AI researchers and developers.
Closer to 600 now, actually.
Oh, there you go. I guess that's fast growth. And, we'll keep you even busier. Things doubled over time. And you also founded artificial intelligence program at Google, which I still think is one of your true master tricks, because that is not very common inside of Google. Bring these creative minds in and see about the combinations there. So let's see what you would have said if you had introduced yourself. What would be the first question that I should ask you? What's the entry? What are you thinking about today?
Well, that's a very kind introduction, Max, and I feel a bit awkward to say anything more about myself after that. But maybe a way to split the difference is to say something about what brought me from Microsoft to Google and why, and therefore what the founding ethos was of the group that I'm now leading, which has as Max said, grown quite rapidly over the nearly 8 years now that I've been at Google, so I can no longer consider myself a Google newbie. And yeah, please anyone break in as well. If there are questions or comments. I know it's a little bit awkward to do this kind of stuff remotely, and I do really miss traveling, as I'm sure many of you do as well. So what brought me from Microsoft to Google around 2013 was that, on the one hand, it was clear that neural nets were experiencing an explosive renaissance, and that those presented a really powerful new frontier for AI. I mean, we're talking about AI now without rolling our eyes. I mean, maybe sometimes in fear, but no longer in disbelief as we were for many decades previously. Many of you probably know that AI was a kind of somewhat silly term that was invented in 1956 at Dartmouth, and underwent many cycles of hype and bust. In the decades between then and roughly 2000 or 2006 or so, and a lot of those cycles were based on ideas about intelligence, about what intelligence looks like, that are both not very much like what happens in our own brains, and that are probably misconstrue what intelligence really is. The idea that you can make intelligence by sort of solving algebra problems, or by chaining together logical propositions, is probably a blind alley. So anyway, neural nets were back. My own background is actually in computational neuroscience, and although this isn't all that well known, the originators of the computer, so all of the pioneers who invented computing, basically, were pretty much all computational neuroscientists as well. So, the fields of neuroscience and computer science really were joined at the hip in the beginning. And it was only when sort of kind of the AI project failed in the 40s and 50s that computers began to diverge. This kind of logic-based, math-based idea of how to do intelligence turned out to be useful for all sorts of things, for calculating the trajectories of missiles, or for balancing spreadsheets, or whatever, but not for doing anything that we recognize as thinking. So, AI and computer science diverged, essentially. There was always this kind of dark path of neural nets and neuromorphic computing and so on, but it kind of went underground for a long, long time. And those things were starting to reconverge, in the early 2010s, and that was very exciting to me, because I felt like my passion and my profession were finally coming back together.
And if I may share, joined at the hip, your wife is a neuroscientist as well.
Yes, so quite literally.
I don't know about your offspring, but they might be the perfect AI researchers and developers then.
Well, I'm not sure. They're actually both Luddites and are kind of anti-computer, but that's another story.
All right.
But yeah, that's right. So my wife is faculty at University of Washington in computational neuroscience, a very similar background to mine, but went the science route rather than the technology route. So AI was back, was roaring back, and that was very exciting. But it was also roaring. Google was at the forefront of that roaring back, and there were some things about that worried me, because there are two reasons that Google was really at the forefront of it, and this was really fueled by Jeff Dean and his brain group. One was that neural networks, at least when you run them on a conventional computer, are very computationally intensive to train and to evaluate. And the reason for that is straightforward. It's that a neural net involves a lot of operations happening in parallel. Our brains are about 100 billion neurons that are all operating in parallel. The clock speed, as it were, is very slow, but all of them are computing at once. And so if you're trying to simulate a neural net on a classical computer, then you need to do that with for loops, right? And so essentially, you're kind of like running over every element, in your virtual brain, millions of times a second or whatever, in order to try to simulate, the parallel operation of a neural net. So of course it requires very powerful classical computers in order to simulate a neural net. And Google had, and still has, as far as I know, the biggest data centers in the world. In other words, access to the most computation in the world. And yes, for loops. Of course, we should never use for loops. Actually, we'll come back to this question of parallel operations, because I think it actually says some very interesting things about where we're headed in the future. But the other thing that Google had in abundance was training data, because it really led the whole web services revolution years before, in which, rather than making computers that people use, as tools on their own, the way Microsoft did, they ran everything from the data center, and all of the data exhausts, all of the usage data that becomes sort of part of becomes a training data set, essentially, that Google can then train with. So they had the data and they had the computation, and that's arguably why they were at the forefront of this whole thing. And that really alarmed me. It alarmed me because, that tends toward a vision in which, we're going to end up with a single giant AI, a single giant brain or robot with its tentacles everywhere in the world. And that struck me as problematic, especially in a world where devices and technology are getting smaller and smaller and more personal and continuous and with us, in everything that we do. And in our daily lives. I mean, Max was talking about things like Fitbit that are, literally almost sort of like bionic attachments, right? That are continually monitoring, some signals from your body. And, for somebody like Max or like myself, or I suspect like many of you who care about some kind of balance of agency between, individuals and larger structures in the society. And I do want to emphasize, I'm not some libertarian who believes in, like the individual at the expense of all social structures. But I do believe that a balance is necessary there. You need a certain amount of privacy, freedom, agency, in order to not feel that your life is subject to to forces so much bigger than you that you lose your humanity. And I worried that that's where things were going. I mean, I may be over dramatizing things slightly, but only slightly, to be honest. I really think that is the direction that all tends. So anyway, sorry, this is a very long introduction, but hopefully I'm getting into technical things as well as just autobiographical stuff.
If you're okay, I'll just break in and throw in a couple of stuff. So please. A bit of dynamic. I totally agree on the data and the computation as the elements that were so favorable in Google's case. Peter Norvig, who we both really value, one of the original AI directors at Google, has a great talk and a paper, The Unreasonable Effectiveness of Data, that I think sums up this data point just very, very vividly, right? To show the difference also between, what changed between the long winter, right, and what brought about the spring and the arguably full-on summer that we are in right now is the access to data and the availability to actually try out and learn from it.
Well, so this actually brings us in a bit of a different direction. I don't want to digress too far, but actually Peter's the unreasonable effectiveness of big data kind of thesis was kind of where Google was just before the neural net revolution. That was what they were doing between, I would say, 2000 and 2010. And so one of my favorite, papers of his from that time was about doing, and actually Franz Och, who started Google Translate, was the other, one of the other kind of main advocates of this approach. Basically, it was kind of like a Chinese room approach, if you've heard of the Chinese room of Searle. It's not using neural nets, it's just using giant tables. And the thesis was that a trivial algorithm, like no algorithm at all, basically, but an enormous amount of data will do to solve all kinds of notionally, AI kinds of tasks. And that was how Translate worked. It basically just collected trillions of tokens of words, 2-word sequences, 3-word sequences, and so on.
And probabilities, yeah.
And it's just calculating probabilities. So it's a raw calculation of probabilities with just from raw words. And it did a better job of translation than all of the kind of more principled, grammar and algebra-based approaches of natural language processing from before. But it was a dead end, and that is important to emphasize. And the reason is that, I mean, for those of you who know anything about statistics or machine learning, there's no regularization when you're just collecting, massive amounts of raw statistics. And what that means is that, for instance, if you run across a sentence that has not been written before, then you can't understand it or translate it or make sense of it. And we know that that's not the case, right? We generalize, when we learn, and that's why we're able to produce novel sentences. It's why you're able to, make sense or some sense a little bit, anyway, of Finnegan's Wake, which is full of words that have never been written before and that you've never seen before, but you kind of get the sense, because they're like other words, they evoke things. So anyway, a bit of an aside, but neural nets, offered ways of doing regularization or generalization that allowed one to solve those problems, but that were still extremely data hungry. They were very, very inefficient in terms of, how much data they needed to learn relative to, say, us, right? We can learn how to speak from a mere lifetime of speech, which is nothing. I mean, a lifetime of speech, everything that you hear in your entire life could probably fit on the shelves of the library that I'm in right now, which is tiny, right? Relative to, the internet or what Google encounters. So a bit of a digression, but
and I did want to suggest you were going into the juicy territory of how to get the AI and the systems happening with privacy in mind.
Right. That's where we're headed. That's where we're headed. So yeah, the group that I started at Google, and that amazingly Google's leadership agreed to let me start, was called Cerebra, which is still its name, and that's the Latin plural of brain, so brains rather than brain. And its basic thesis was, what if we change Google from just being a giant robot in the sky to a robot factory? So make it a manufacturer of brains on the premise that the future is not a future where there's, one single AI, but rather a future in which you have an AI and I have an AI and Max has an AI and, Wolfsburg 42 has an AI and, and so on. So it's a multi AI universe. That required solving two central problems. The two problems are, first, get to a point where neural nets can actually run on small devices as opposed to giant data centers. So that's solving the inference problem. That turns out to be possible if you just write the code a lot more efficiently and focus on neural net size and power consumption and so on. And so the team, began doing a lot of this kind of work, and we shipped neural nets that run on Androids and Pixel phones and so on, early on, and did all kinds of interesting things in that way. Like one of the earliest examples was something called Now Playing, which works kind of like Shazam. It recognizes the songs in the environment, but unlike Shazam, it runs locally. And the reason that that's a lot better is because now, if you're in the cafe and something cool is playing, like the name of the song is on your lock screen. And you're like, shit, that's amazing. Like the song is on the lock screen. Does that mean that it actually sent, the company, like the audio of everything that I'm hearing? No, the recognition is all happening locally. The data isn't going anywhere. And that makes it able to run continuously. Whereas if it were a service, then running continuously would mean like the phone is literally streaming audio continuously to the cloud, which is a surveillance nightmare, right? So it lets you do things that are not possible to do legally or morally, otherwise, or even technically. But the other problem, which was actually, I think, quite a bit harder than just shrinking neural nets to run on devices, was how to learn. Because, if you're no longer running a service where all of the data is flowing through the servers, then you're kind of throwing away the seed corn. Like, how do you improve such a system? How do you train it? How do you measure, how well it's performing? This is like the lifeblood of companies like Google, right? That they're able to not only deploy a system, but test it, in real time against, 1,000 and then 1 million and then 1 billion users, and gather all of the training data that will make the next generation of the thing better and so on. So
and you might remember that one of the sponsors in Wolfsburg is Volkswagen, and they had
automotive is very relevant here.
enormous effort to finally get to the point where they can do over-the-air updates on the cars. That was one of the major advances that Tesla really pushed throughout the industry. And I mean, this is basically, the seed of doing what is federated learning on device AI. These things that you're talking about, I mean, not even thinkable without improving the devices over time.
Exactly. And somebody actually put into the chat, Tesla announced a new chip specifically for training neural networks, if I'm not mistaken. So yes, the reasons for doing this are clear, right? The car or the phone or whatever the device is, large or small, right? That is where the data live, right? Whatever the sensors are, that's where the data begin. The moment you start to move the data around, issues arise. First of all, moving data is expensive. It costs energy, especially if it's very large data. Secondly, it compromises the privacy of everybody involved. And it shifts power balances. I mean, in cars, this is, I think especially troubling because, for instance, if suppose that I have an audio feed from inside the car, you need such an audio feed if you're going to do things like, be able to command the car with your voice. But now that means that it's picking up every conversation you have in the car. This is not just your privacy, right? It's the privacy of anybody else who happens to be in the car with you speaking. So, the idea of having an open mic, right, from the inside of the car to the company that made the car so that they can surveil everything that you're hearing is obviously horrible. And by the way, I mean, even if you trust the company, even if you believe that the company, is going to do no evil or whatever, you all know as well as I do that those data centers can be tapped by the governments in which they live, if it's a fairly progressive government, then there may be some legal constraints on that. There may be subpoenas necessary or whatever. If it's a less progressive government, then it can be just simple mass surveillance. And as Snowden's revelations a few years ago reveal, even in the U.S. and for that matter in Germany and various other of the Five Eyes countries, there is absolutely a mass surveillance happening of that sort, whether or not within the strictures of the law. So.
Please, as you're bringing this up, what's your take then on the hot words? Does it work? Is it a viable solution for the moment, for a long term?
I think hot words suck. So hot words are a hack. When you don't have powerful enough neural nets to actually, understand the speech and act on it locally, then you can say, well, what about having a tiny neural net that is just able to recognize, Google or, hi Cortana or whatever, then you have a small neural net and then it catches, whatever words or phrases surround that and sends those. Now, that's better, obviously, than having an open mic. So, it's an improvement. However, here are a few of the many problems. First, there's an asymmetry between over-triggering and under-triggering, in the sense that if you under-trigger, then it's annoying to the user because it doesn't work, half the time or something, right? So nobody wants to under-trigger because then you're making a product that feels broken. But on the other hand, there's no user penalty, if you like. There's no perceptual problem with over-triggering in which it activates all the time. But when you're over-triggering, that means that there is a lot of bycatch. It's a little bit like the nets that are supposed to catch tuna, but also catch dolphin, right? So all kinds of private things end up in the data center, and now you're back to a bad situation. But also more fundamentally, there are a couple of issues. One is all of the kind of social awareness that you might want to have if you're an AI in the car, say interacting with people in a reasonable way, right? Like we know when we can break in, when not. Like if you're about to miss your exit, we might break in, but if it's, otherwise we don't. Like you speak in an appropriate volume. I mean, like none of that social awareness can happen with a hot word type system because, that little tiny neural net is just too stupid to be able to do anything like that. And it isn't connected to the real AI that is actually processing the sentences. There's also a conceptual problem that I think is quite profound, which is that none of the companies who make things that have hot words have actually been able to answer the question, is the hot word detector part of the assistant or not? And this is a tricky one because if you say, yeah, it's part of the assistant, right? It's part of the same thing. Then the conclusion is, well, the assistant is always listening. right? And the whole reason that they're making the hot word detector is because they want to say, no, the assistant is not always listening. And then if you say, well, no, it's not part of the assistant, it's separate. Nobody has a name for what that separate thing is yet. So what is listening if it's not the assistant? Is there like a little assistant that is listening, and then then it'll wake up the big assistant? Like, nobody has language for this. So I think it also screws around with our mental models of what's going on in ways that are pretty unhelpful, not only with respect to how we can reason about it socially, but also with respect to how you can regulate, or how you can talk about about laws or norms, right, in this environment.
And Blaise, I know that you have your story very straight. That's why I'm, I believe, okay to pull you a little bit left and right. There is an initiative that I recently learned about, the Open Voice Network, and they seem to look into kind of open standardizing exactly those voice interactions. And I remember we had a poster, a talk at Google where it said, teach the computer to speak human, not the other way around, right? So we don't have to learn how to speak to the bloody thing, but we just use our natural language, as the scientific term already implies. Do you think that's a good route, the Open Voice Network, trying to get some coherence across players, or is it actually, a cul-de-sac and not very helpful in the long term? Well,
I think that it's more cul-de-sac than not. I've only looked at it briefly, so I'm going to be speaking a little bit out of my butt on this one. A caveat, right, that this is a superficial read, but my sense about Open Voice Network is that it is assuming that the technology is more or less fixed as it is today, and it's about how you can build better norms or standards around that system. It strikes me as a little bit like the way I don't know if the IEEE were going to make standards for interactive voice response systems, right, on phones. They could be done better, and we could standardize which keys you use, right, for different kinds of, like, make 0 always be the operator, and and so on.
And it's kind of a faster horses type of thing.
Exactly. It's a faster horses kind of thing. I think that the reality is that that very soon, people have brought up chips that are designed for actually running neural nets efficiently. Apple, everybody else is coming out with them actually, and and if you follow that technological path, not very far, just a small handful of years, 2, 3, 4 years, we are going to be able to have entire, not just assistants, but real AIs, real strong AIs that can run locally on devices. Is it worth standardizing some things about how those work? Yeah, it is. But at the same time, their real power is not in building standards around them, but actually in having them, adapt to and become, human actors that don't require, any adaptation on our part. And then it becomes more a question of, what norms, how we essentially require that common sense human norms apply to the behavior of such AI actors, which is, kind of a different level of regulation and norm making than Open Voice Network. Does that make sense?
I think so. And let's see if it triggered some questions from folks. But yeah, wonderful. And I felt the same way, but about the Open Voice Network. But then I thought it's also nice that they start to talk across different organizations. It might not be useful in as an end result, but it might be good as a process. And in terms,
I agree with that. I agree with that. It's good. It's good to start having the organizations communicate, and that I certainly don't want to downplay. That is important. There's not enough of that going on, it's frustrating. I've tried to do a lot of stuff, between, say, Google and other large phone makers, and it's difficult to get the companies to just agree on things and agree not to compete in certain areas and to just make certain things baselines. That's it's one of the prices that we pay for this kind of semi I don't want to say monopolistic, I guess, but for late stage capitalism, let's say, in which there are very large players kind of competing with each other without much of a sense of common good.
Okay, so let me pull you back into the scenario that you were describing. On-device, federated learning, right? There are parts that are smart, I guess, that really deserve the name, and somewhat autonomous in their smartness. How do they interact? What's that world like that we live in?
Well, I mean, I think that the natural way for AIs to interact is the same way we interact, using language. This is why, I'm sure you all have seen things like GPT-3, and, there are larger and more powerful models that are not public, or that have only been shown publicly, in little snippets like Lambda. And the reason that those are so exciting, from my perspective, is that they show that we finally start to have machines that can interact with humans and by extension with each other. In ways that are fully legible to humans. Language is an incredibly powerful API, if you want to think about it that way. And it's not going to go obsolete, right? German and English are still going to be around in 500 years' time. Unlike various crappy APIs and standards and things. And it'd be pretty great if if English or German or whatever just worked, right, as a way for pieces of technology to interact with each other in a way that is legible, understandable to us, is compact, is generalizable, is future proof. So yeah, I see language as really the key, and it's open ended. It allows ideas to be expressed, as simple as light turn on or light turn off, and as complex as Kant or Joyce, right? And in that sense, it's open ended in a way that no rigid API is. And this is exactly why the kind of classical approaches to AI failed, right? Because they approached general intelligence or whatever as something that we could somehow arrive at through things like APIs and schemas. And if there's nothing else we should have learned, in the past 10 years, it's that we're never going to get anywhere with schemas that purport to be future proof.
And 42 universe software engineers, next generation and current, just see what Blaise is saying there in terms of APIs, really discovering what they can do, right? And learning how to speak to each other. What a freaking hassle, the, backwards compatibility, all these scenarios that you don't envision as a coder when you set up the software, right? You don't know where it's going to be used. And what you're describing, Blaise, I think is really enabling a tech environment that's much more organic in a way, right? Able to adapt to different scenarios and so on. So really exciting. As I imagine there will be a bunch of folks following up with questions. Blaise, you should tell us at the end where to find what you'd recommend in terms of resources to read up and so on to learn and get involved in some of the projects that might have open aspects to them. Sure. But if I don't know if you want to go on a little bit longer on the on your vision, your perspective on what's a desirable system, we could, or I could move a little further in the flow that I thought about.
We should do that. We should move on. I mean, the only thing that I feel like I that is really important that I haven't said yet from my perspective is I was doing a bit of a long wind up toward federated learning, and it's probably useful to just say what that is and why it's important. But yeah, we should then move on, and we should save some time for discussion as well. But yeah, I we rewind a little bit. I said something about the importance of being able to evaluate neural nets on small devices, and about the problem of not gathering all the data into the center, and therefore not being able to iterate, or develop such neural nets. So the really big challenge, is how do you learn neural nets, not just evaluate them in an environment where the data never leaves a device. And we came up with a solution to that a number of, really in the first year that I was at Google and began publishing a few years ago about it. And it's called Federated Learning. There's a comic book that it describes how it's used, which is actually pretty good. I don't know if Max, if you Google Federated Learning comic book, and maybe you could paste the link in.
Yeah, I'll do that. I do not know the comic.
There's a comic. We made a comic because we wanted it to be understandable even by policymakers, which is hard apparently. But the idea is very simple. It's that when you do machine learning normally, yes, thank you, Mio. That's the one. When you do machine learning normally, what you do is you break up the training data into sets or batches, and those batches are distributed across many cores in a data center, and each of those cores evaluates the gradient of all of the parameters with its own batch of data and sends those gradients to a parameter server, which adds up all of the gradients and evolves the weights and then sends the updated new best neural net back out to all of the workers. This is the stochastic gradient descent algorithm. Now, it's the conceptual move is very simple, which is just imagine that rather than distributing it out a bunch of cores in the data center, you are distributing the learning task across all of the phones or devices, cars, whatever they are, where the data actually live. And your batch of data is whatever data you've got. So every device calculates gradients or on its own copy of the neural net and sends those gradient updates to a server. The server adds them all up and sends a new neural net out. There's one more twist to this, which is that if you just there's sort of a privacy challenge of like, can you reconstruct the training data from the gradients of a single worker? Could you guess what it encountered that is causing it to learn the thing that it's learning? And the answer is, if there are too few training data samples, or they're too similar, then you can do some kind of such reconstruction. But obviously, if you've aggregated over enough data, then you stop being able to reconstruct those individual samples, because otherwise your neural net is not actually learning anything, right? The whole idea of neural nets is that they generalize rather than memorize their individual examples. So the trick is something called secure aggregation, in which those gradient updates from all of the workers are compressed and encrypted in such a way that when the server is adding them all together, it can't actually decode any of those updates until 1,000 of them have been added together, and then that sum is able to be decoded. But only the sum, as opposed to the parts, can be decoded. So you add that kind of bit of crypto magic in, and now you have federated learning with secure aggregation, which is a way to make a giant distributed supercomputer out of everybody's phone or car or whatever that can learn from really big data. Bigger data than you could ever gather in the data center. It's almost like the dark matter of big data, I've called it sometimes, while preserving everybody's privacy. So this is, it's very exciting to me. You're probably hearing my enthusiasm as I'm talking, because it breaks that trade-off between big data and privacy. Like now you can do both. So we've been using this now for years to train Google's keyboard and camera and a whole bunch of other things that run on the cell phone. And it's also now being used in healthcare, in health applications, in order to be able to learn patterns in medical data without having breaking laws or violating people's privacy. So I'm very excited by this development. I think it's probably the single most important thing we've done in the team.
Really, really cool. And if I may shift gears a little bit, I wanted to see how you describe good learning conditions and what might be your practices, things that you've found over the years that work for peer learning or learning in general. I have to say that I think you're a perfect example of a knowledge entrepreneur, right? Somebody who's really entrepreneurial, looking for opportunities, but not necessarily to make money, but to learn and find out more stuff. Just to share with our audience, when we were working together at that time, I think you had at least a handful, probably more, Mechanical Turk, operations running kind of as a side project just because you were curious about them and you had trained a population to give you answers to certain questions. And I think you did it mostly because you were amazed by the fact that you could. And then you asked it relevant questions and then used that indeed to argue for changes in your programs and for new stuff at Google. So that kind of practice, are there any that you like, any things that you'd want to share with our population of aspiring software engineers?
Yeah, I mean, it's a great question. I'm definitely not a Peter Thiel type who believes that like we should abolish universities and academia has no value or whatever. Those kinds of institutions, they do really matter. And, I've actually just finished reading a book that I've enjoyed very much that, others might, who are into this kind of stuff might enjoy too, called The Weirdest People in the World. Joseph Henrich is the author. Okay. Weird stands for Western, educated, industrialized, rich, and democratic. So it's everybody in this room, probably. To a high degree, we represent the very, very small minority of people who have ever existed, who have ever lived on Earth, and even a minority today on Earth. As much as I don't want to be Western centric or bigoted in other ways, like this, the things that have come along with this weird package of social norms, they have been an enormous boost to our well-being, our comfort. I mean, they also have allowed us to reproduce, to a degree that now endangers the planet. So let's not oversell it either. But basically everything, all of the technologies and cultural things that we care about, are functions of this cultural package. And things like universities and institutions that that are able to sort of serve as concentrators of certain kinds of knowledge, they are part of that package. So I don't want to sort of degrade, right, the importance of those things. However, I've also never taken a computer science course in my life. I learned everything that I know about computer science by hacking, and I suspect that's true of many of you as well. So in my opinion, the things that really benefit from institutional knowledge are things that either are very theoretically deep and that require a level of mentorship from experts, like math, right? Like advanced physics, that you just can't get from some YouTube videos and shit, right? Or that involve a degree of cultural accumulation that you really need schools of thought to pick your way through, and this is true in certain humanities. So I think those things are very valuable, but we also have books. I'm not a huge fan of the learn everything from Khan Academy type approach, but learning from peers, especially peers who have taken the time to organize their thoughts carefully and build out arguments in detail is obviously fundamental to how society advances as well. I mean, one of the big things that Weird did was advanced literacy during the Protestant Reformation, right? And that was a huge enabler of everything that we have in society today. So yeah, I'm a fan, but I guess I do also have these caveats, about let's not be anti-institutional about it either.
Yeah, we're on the same page. We're actually good friends with the neighboring universities. We've drawn in experts from industry and academia to mentor our students. And I hope many in the 42 universe will have that opportunity in the future. That it's something that proves relevant and good in the network. There's one example of the stuff that I learned from you that I wanted to share and see if I misquote you. Please hit me over the head. But I remember that. There is a change from product launches from pre-machine learning to any product that includes machine learning aspects. And that is, you don't just release it on the world, have a great party and show it to the world and then sell it everywhere. You really want to do beta testing in a variety of community and use cases to make sure it's actually resilient and doesn't show any properties that you simply couldn't imagine and didn't foresee. And I thought that was really deep and insightful as a general practice for our field.
I agree. I mean, I don't think that should have been restricted to just ML models. I think it's a very general engineering problem. I mean, you can even find it in the engineering of physical things, of devices, of juicers, of whatever, right? There's always a fairness, accountability, transparency, like all of those things matter for every kind of engineering, but they're especially salient in machine learning models that use large amounts of data, because there are always biases, in those data. And that means that, it's very difficult to spot any of the issues from any of the code that any of the engineers actually wrote, right? You have to actually measure those things and understand them in a situated way.
Cool. So that brings me to my last point, and then we can open it up. Folks, please raise your hand or put questions in the chat. So we get ready already. We built, you probably know the Manual of Civilization from the Long Now Foundation, right? They're collecting 1,000 books to explain to a potential alien or future society what this is all about. We're doing something similar for software engineers. We're looking for the 1,000 books that make happy software engineers. And of course, a happy software engineer is one who really excels in the trade, but also knows things about pace and good habits and organizations. So we get recommendations from folks like Ted Hardy and Vint and so on, but also from Doris Sommer, who you met at the conference in Berlin, right? So I'm just listening to 100 Years of Solitude, for example, to balance my brain, right? I think it's a really, she made a very strong point, I thought, that, technologists should get involved in humanities stuff and that there is a third culture and so on. So we're looking for your book recommendation, 1, 2, you might also come back later, that you think has a high half-life, right? Not something that you've just read, which you already shared, which I'm sure is awesome, but not sure what you'd say about it in 10 years if it shows up in your long list. Do you have a book or two that software engineers should read to prime their brains?
Boy, yeah. The main problem is actually narrowing it down. I mean, I have lots of good candidates. I guess, if we're going to really go far afield, really far afield, then maybe a book that I would recommend that you're not going to get a recommendation from anywhere else is called Chav Solidarity by D.P. Hunter.
Okay.
It is an autobiographical series of short essays by somebody who is half Irish gypsy and grew up extremely poor under absolutely appalling circumstances in the UK. It's self-published. It's full of grammar errors and things. It really, exposes, I think, some very interesting perspectives on what life is like for people who are, actually, much more common than one imagines, right? As we are, even in Western societies, even in rich societies, right? We're still like a palimpsest of different kinds of cultural constructs living on top of each other. Communities like the one that he grew up in use entirely cash, of course, because they were operating in a kind of black and gray market economy. None of the social constructs, right, that we take for granted, whether that's forms, banks, schools, social programs, and so on. Like anytime you have to fill out a form, they have to essentially make things up because none of their constructs work with what we've got. So yeah, this is this
Very
gives
cool,
you, if you like, an ethnographic perspective on what is on what is happening in our own world. It's almost like China Miéville wrote a novel called The City in the City a number of years ago that imagines that people live in the same city, but it's like two cities overlaid on top of each other and don't see each other. This is the real life of that.
Very cool. And, it's really the kind of stuff that takes us out of our own perspective. We, in Wolfsburg, took up the Burning Man principle of radical inclusion as one of our first values that we live in. We have 30 nations in our 150 student body in the moment, right? Really diverse 18-year-olds reviewing the code of 50-year-olds, right? And all these dynamics. And of course, as you would expect, we have discussions around freedom of expression and where is the end of tolerance, the end of integration and so on. Okay, great talk. I would love to pass the floor to someone who is willing to ask his question over video, or I think there are a couple of questions also in the chat that you're welcome to choose from.
Yeah, I mean, a lot of the stuff in the chat is, comments that are really smart and that I 100% agree with. I'm not. I would welcome things by voice, because I think these are.
And this is a moment for all those introverts, especially on these strange video calls with 96 people on them. Just unmute. There is no such thing as a bad question, and we'd love to hear from around the world. I definitely see folks from Sao Paulo. Welcome. From Tokyo, I think I saw a colleague.
Let's see, we have a new message as well. With the whole discussion that society is having about big tech being too big, do you think development and progress have become too centralized? Well, I mean, I do think that inequality has risen to levels that are super unhealthy. Max and I have talked often about why thinking about distribution of wealth differently is so critical to healthy futures. But as with everything, there's sort of a narrative and a counter narrative here. I think the inequality of wealth is obviously too high. When I think about centralization of development progress, I guess I do think that a lot of the platforms are too centralized. But I also think that the level of coding, if you like, that can be done by people with no formal relationships, just on GitHub or whatever, that has actually risen to meet the level of coding that can happen at the big companies. So, even when I joined Google, there was still a lot of big talk at Google about how we have the best tools internally. And, when I joined Google, it was like the lights went on and everything worked and so on. Now it's the opposite. Actually dropping everything inside Google and just going and working on GitHub and using open source is better. So, so I think that we're actually in a stage now where the companies, if anything, are in certain ways behind what can be done. Just by piecing together stuff that is out there. I mean, archive and all of the papers are open. So much of the source code is open. I think that the centralization issues are more ones of platform versus coding, if that makes sense. Henne, I think you have your hands up.
Yes, I've got a question. So we've been talking in the chat about AI as like a personal assistant, and we all know about examples where AI was able to recognize cancer or stuff like that. It seems like the possibilities are limitless, or do you think there is like a limit for AI that AI will never be able to do?
No, I don't think, at least that anything that we can conceive as people is a real limit. I think there's a lot of talk about what makes us uniquely human. I've heard people argue, in ways that I haven't heard for a long time, for like human souls or stuff like this, and that's so obviously all bullshit. I have a lot of affection for humanity with all of its, with all of its weird, evolutionary baggage and so on. And I'm not saying that it would be simple to make a machine that reproduces all of the weird quirks that we've got. Neither would it be a good idea, by the way. But yeah, I don't see anything that, any intrinsic limit, or like, machines can't do this or that, at least that we can, easily conceive or understand, other than basic limits, basic theoretical limits, of computation or computer science.
And that, of course, would make for a great other talk. I put in Daniel Dennett just as a really good reference in that space. And he's one of the leading philosophers alive, and he makes that argument about the non-uniqueness of the human brain very strongly. And I think it. Yeah,
this is, by the way, his most recent book, which I like a lot, From Bacteria to Bach and Back. Dennett is very good. I agree. Sorry.
Yeah. Okay, sorry. There's more. Two more questions. Let's squeeze them in. Please, I think, Valentin, you were first.
Hello. So I would like to ask, in your opinion, and I'm asking this because there are a lot of different versions over this, what is the difference between pattern recognition and understanding? Because there's been a lot of hype going on that NLP is not NLU. And I'm talking here about, of course, OpenAI's GPT-3, that is only just a really big network and it will only reproduce what is heard.
Yeah. So having interacted with networks like GPT-3 and bigger, and had real conversations with them, it is honestly, it's really hard to have those conversations with such a network without having the hair on the back of your arms stand up. I think that, on the one hand, those kinds of systems are they come across as subtly but profoundly impaired relative to the human brain in certain ways, that become clear when you understand that, for instance, they don't have any sense of time, and they have no perceptual inputs other than text. Right. And they learn from everything at once. So that it's kind of a massively parallel as opposed to, like real serial understanding, of the universe. Right. So they because there's so much, because they learn from so much, they can sort of figure certain things out, figure out certain regularities that you wouldn't think could be figured out in that way. But that doesn't mean that they understand everything. They can kind of bullshit as well. But to go from that to say, oh, they're just stochastic parrots, they're just reproducing statistics, I think is to not understand that that's exactly what we are as well. Plus emotions, obviously, and lower brain functions, right? So I don't want to downplay those lower brain functions either, and they don't have that. They're more like a pure cortex. But it is very difficult to have a conversation with one of those systems and not come away with the sense that there is somebody home, and that there is a real understanding there. It's not just statistics. You can play gotcha sorts of games, but you can gotcha with other humans as well, quite easily.
As a quick follow-up question, so do you happen to know of a data set that I could use? I've just been granted permission to OpenAI's GPT-3. And so, but I don't have a data set on which to actually test it. And so, do you happen to have any resources for that?
I don't. I guess I don't know quite what you're after. You certainly can download large corpora of text from, Wikipedia, Project Gutenberg. A bunch of these things were used as part of the large-scale training data for the unsupervised stage of things like GPT-3. So if you're saying something that was not part of that unsupervised set, I don't know any easy way, because they've kind of expressly gotten as big of unsupervised data sets as they can.
Blaise, we are over time. I don't. Your call. I don't know what your schedule says. If we do have one more question,
I'm pretty sure I can. I'm pretty sure I can go over a little bit. Let me just double check that there's nothing absolutely critical.
This is why he's so nice, and this is why many times he's late. Vinicius,
that's true.
Why don't you throw out?
Yeah, just one more question.
Okay, wonderful.
Or actually, I see there. I can take two.
Sao Paulo.
Okay. Greetings. I would like to know your opinion about Comma AI Open Pilot. I don't know if you heard about it.
Yeah, I saw the chat. I actually have not checked it out. So I clicked the link so that I could check it out later. But yeah, I'm sorry, I don't have. I haven't seen it.
One thing, there's only one thing I'd like to know a bit is the company was founded by George Hotz, and he says that the approach that Tesla and the other companies have on self-driving artificial intelligence is a bit how can I say? He says that self-driving AI should drive like humans do, and not on a perfect system, like without errors and stuff. And it even says here that artificial intelligence software and consumer-grade cameras are good enough to allow clever tinkerer to create a low-cost self-driving system. And
so Vinicius, let me quickly come in. I'm happy to follow up with you. We are actually planning to buy a Comma AI set in Wolfsburg and test it out. Oh, cool. So this is the guy, Blaise, who gave us the jailbreak for the iPhone back in the day. He was 18 and now he's kind of hacking cars and setting his own boxes on top. And basically his argument is they're exaggerating that the cars don't need to be perfect as long as they're better as a human. So it's really interesting, and I definitely need to check this out. I'm hearing things that I agree with for sure, but I also, I guess, I don't know. I mean, the question that it raises, and I think this is a pretty deep one, is whether we're going to be utilitarian about this, meaning like if it performs just better than a human at all, then we'll take it, right? We know that humans suck as drivers, right? So even if you had something that is runs people over just 20% less, like it would still be like a trolley problem moral failing to not adopt it, right? And from a utilitarian standpoint, I agree with that, although obviously it would be very, very difficult to get something like that past, any kind of government or regulatory body or whatever. So, it opens, I think, a really interesting problem, kind of public policy problem for us, if you like. And I would love to engage that more deeply, but I need to learn a little more about what Comma AI is doing. That commodity sensors can do all of this, I don't doubt. Learn a little more and learn about something that we might be helpful to help learn together. I'd love to do that, Blaise. This was absolutely super cool. The chat's already agreeing. I hope we see each other again soon. All the best to Seattle, and hasta la vista.
Likewise, and all the best to Wolfsburg. And thank you all so much for having me. This has been really fun for me too.
Cool.
Cheers.
Bye. Cheers.